This is Dr. Alemi, and I would like to show you how Excel can be used to create risk-adjusted P-charts. Take a look at our data. We have 6 weeks of data, and we have up to 6 patients on which we have risk of infection. And we also have a column H, which shows the number of infected people and of the total sample. So we begin with calculation of observed mortality rate. So that's simply the average, it's simply the number of infected people divided by the sample size. And we're not talking about mortality here, we're talking about observed infection rate. And we want to display this as a number. We can drag this down to calculate it for all of the 6 weeks. So we start at probability of infection being 1, everybody getting infected, and we go on the 6th week to 1/3 being infected. The next step is to calculate the expected infection rate, and that is equal to the average of individual probabilities of infection. And we can copy this down as well. The next step is to calculate the expected deviations. For each time period, but to do that, we need to actually calculate a different variable, and that is we need to multiply each expected value times 1 minus the expected value, and we need to do this for each month. So here we start with the expected value for the first person multiplied by 1 minus the expected value for the first person. So that is 900, and we drag this down 1, 2, 3, 4, 5, 6 persons. Just checking that the last one was picked up. We do the same thing for all of our week 1 values as well as all other weeks. Some of the these zeros are missing data, so they shouldn't be there. Okay. We calculate the sum for each one of the time periods. And that's simply sum of these values. And this is week 1 through so we're going to drag the sum down so we're going to calculate it for all of the weeks. Now we are ready to calculate the expected deviation, and expected deviation is this square root of the sum. divided by the count of the number of cases in that time period. We can now drag this down so that we have expected deviation for each time period. Upper control limit for the first time period is equal to the expected infection rate, which is 0.83, plus t times the deviation, expected deviation. Now the t-value for 6 data points is larger than 2.37, so I'm going to actually just put 2.40 roughly for that t-value. Times the expected deviation. Actually, I went and looked up the t-values for 5 degrees of freedom. For a sample of size 6, we have to take one less because of the sample size, an estimation of one parameter. So the t-value is 2.571 for 95% confidence interval. Now, we have to go in this, so the upper control limit for each one of the time periods can be dragged down. But the t-values have to be different. For this one, it's okay. It could be that value. For the third one, it's only 4 cases at 3.182. So this should be 3.182. And for the next one is also 3.182. And for the 5th time period, we have 6 data observations, and that we are okay. And for the last one, it should also be 3.182. The lower control limit can be calculated the same way. It is the expected infection rate times 2.571 times the expected deviation. I'm going to drag this down, and we have to change it for the situations where the t changes, and it is 3.182 in this situation, and also in the next one 3.182, and this one is correct, and the last one is 3.182 as well. Oh, I made a mistake here. It has to be minus here. So let's try this one more time. And let's go change them where it's necessary to change to 3.182. Okay, now we have to make some corrections. The probabilities cannot be more than 1, so I'm going to reset this to 1. And the lower control limits cannot be negative. Probabilities are always positive numbers. So I'm going to reset that to 0. We are now ready to plot this. So we are going to plot the observation infection rates and the lower control limit. I'm going to, after I plot the lines, I'm going to remove the expected infection and expected deviations. I'm going to choose a line chart. So we don't want expected deviation, which is the gray line. And we don't want the expected infection rate, which is this line. We do want the observed and the upper and lower control limit, but we want the observed rate to the upper control limit to be all red. And similarly, we want the lower control limit to be all red. We want the observations to have markers. And we want to put axis titles. And this axis is time period. And we want everything bold and in black line numbers so that it can be easily seen. And that's our control risk adjusted control chart. It seems that everything is within the limits.